Dart Analyzer. The Dart Analyzer is a static analysis tool that checks Dart code for errors, warnings, and lints. It is essential for ensuring code quality and adherence to conventions. Running the Dart Analyze command in the terminal will start the Dart Analyzer tool. This checks the code in the current Dart project for any static analysis issues. If there are any problems, it will list them with details such as the severity of the issue, the file where it occurs, and the line number. This helps developers to locate and resolve potential bugs and improve the code quality before runtime. Dart Formatter. The Dart Formatter, also known as Dart FMT, is a tool that automatically formats Dart code, ensuring a consistent style across your codebase. Its purpose is to make code easier to read and maintain by applying a uniform formatting standard. The Dart FMT tool has been applied to the before formatting code, adding necessary spaces, indentations, and line breaks where appropriate. The after formatting version is easier to read and adheres to the Dart style guide. The Dart formatter can be run from the command line or integrated into text editors and IDEs for automatic formatting. Dart2.js. Dart2.js is a compiler that translates Dart code into efficient JavaScript code so that Dart applications can run in a web browser. The command above invokes the Dart2.js compiler with optimization level 2, which is a balance between code size and performance, and outputs the compiled JavaScript to output.js. It takes the main.dart file as input. Dev Compiler. The Dart Dev Compiler, DDC, is designed to provide a development environment for Dart that enables a fast edit refresh cycle. It compiles Dart into modular JavaScript that is meant for use with modern web browsers during development. It optimizes for quick compilation and updating, with the understanding that further optimization will happen when preparing for production deployment using Dart2.js. Dev Compiler isn't used directly in code, but rather through your build process or a command in your terminal. It helps you test and debug your Dart web applications in browsers, giving you a smoother and more efficient development workflow. DOM manipulation. DOM, Document Object Model, manipulation in Dart involves interacting with and modifying the HTML of a web page. In Dart, this is typically done using the Dart HTML library, which provides functionality to access and modify the HTML elements, listen to events, and update the CSS styles. The code imports the Dart HTML library and then proceeds to find an HTML element with the ID myElementID. It utilizes the query selector method to locate the element. After finding the element, it changes its text content to Hello Dart. This illustrates how you can select and modify HTML elements' properties using Dart. Using web libraries. In Dart, you can use web libraries to interact with the browser's API, manipulate the DOM, and handle events. A common library used for this is Dart HTML, which provides a Dart interface to HTML5 features. The code imports the Dart HTML library, which is essential for web programming in Dart. The main function, which is the entry point of the Dart web app, uses query selector to find an HTML element with the ID of some ID. It then sets the text inside this element to Hello Dart. This is a basic interaction with the DOM using Dart. Working with HTTP. HTTP, Hypertext Transfer Protocol, is the foundation of data communication for the web. In Dart, we use the HTTP package to make HTTP requests, such as get, post, put, and delete. In this example, we'll make a simple GET request to retrieve data from a REST API. The code imports the HTTP package and defines the main function as asynchronous because HTTP requests are I/O bound and potentially long-running operations. The URL variable holds the URI of the resource we want to fetch. The htip.get method is used to make a GET request to that URI. An if statement checks if the response status code is 200, OK. If true, it prints out the body of the response. Otherwise, it prints an error message indicating the request failed. Single-page applications. Single-page applications, SPAs, are web applications that load a single HTML page and dynamically update that page as the user interacts with the app. Dart, through frameworks like AngularDart, allows developers to build efficient SPAs. Below is a simple example using Dart and HTML. The given code shows us a basic Dart script that targets an HTML element with the ID output and sets its text content. The corresponding HTML includes a single div element for displaying content changed by Dart code. This serves as the entry point for a SPA, where further interaction would dynamically update this div or other parts of the page without requiring a full page reload. Setting up Flutter SDK. To begin mobile development with Flutter, the first step is to set up the Flutter SDK on your system. This process includes downloading the Flutter SDK and adding it to your system's path to access Flutter commands from any terminal window. The provided snippet is a sequence of commands you typically run in a terminal on a Unix-like system. Firstly, you download the Flutter SDK from the official Flutter website. After extracting it to a location on your file system, you need to add the Flutter bin directory to your system's path variable. This action allows you to run Flutter commands from any terminal window. Finally, running Flutter Doctor checks for any missing dependencies and provides guidance on how to resolve any issues detected. Flutter project structure. When you create a new Flutter project, it generates a standard directory structure. Understanding this structure is key to effectively building your apps. Flutter's project structure can be seen as a hierarchy of directories and files. The lib folder is where you'll spend most of your time writing Dart code for your app. The pubspec.yaml file is used to manage assets and dependencies. Within lib, the main.dart file is the entry point of the application. Folders like Android and iOS contain platform-specific native code. Test is used for writing test cases. Other notable directories include assets for images and other resources, and widgets for custom widget classes if you choose to organize them that way. State management. In Flutter, state refers to the information that can read synchronously when the widget is built and might change during the lifetime of the widget. It's crucial for managing data and interfaces in Flutter apps. Here, we're introducing a simple stateful widget, implementing a counter. The code defines a counter widget class that extends stateful widget, indicating it's a widget with mutable state. The counter widget state class contains the state for counter widget, such as the counter variable. The method call increment counter is used to increment the counter and call setState, which triggers a rebuild of the widget to reflect the updated state. The build method describes the UI, which displays the counter value on screen and provides a button to increment it. When the button is tapped, score increment counter is called, updating the UI. Widgets and UI. In Flutter, widgets are the basic building blocks of the user interface, UI. Every element on the screen is a widget, from a simple text to a complex layout. Widgets describe what their view should look like given their current configuration and state. When a widget's state changes, the widget rebuilds its description, which the framework diffs against the previous description to determine the minimal changes needed in the UI. The code defines a simple Flutter application that uses basic widgets. Material app is the root widget, providing material design. Scaffold provides a high-level structure to the layout with an app bar and a body. Inside the body, center is a layout widget that centers its child, which in this case is a text widget that displays Hello World. This structure represents the UI of the app with a top bar and centered text. Working with animations. In Flutter, you can create simple animations using the animation controller class, which controls the animation. It generates values that can be used by an animated builder or an animated widget to update the UI. Let's create a basic animation of a container changing its size. Making network requests. To make network requests in Flutter, you typically use the HTTP package. This example demonstrates how to perform a GET request to retrieve data from a RESTful API. In this snippet, the fetchData function makes a GET request to a placeholder API using the http.get method. It awaits the asynchronous operation of getting a response from the specified URI. The status code is checked to determine if the response is successful, status code 200. If successful, the body of the response, which contains the data, is returned. If not, an exception is thrown indicating that the album data could not be retrieved. This is a simple example to start with network requests in Flutter. Integration with Firebase. Firebase is a suite of cloud-based services designed to support applications. Integrating Firebase into a Flutter app involves a few steps, such as creating a Firebase project, configuring your app to use Firebase, and adding Firebase SDKs. Here, we will look at the initial setup for Firebase in a Flutter application. In this code, Firebase core is included in the pubspec.yaml file to add the Firebase core dependency, which is essential for connecting your app to Firebase services. In the main function, widgets flutter binding.ensure initialized ensures that you have an instance of the widgets binding, which is necessary before initializing Firebase. Firebase.initializeApp asynchronously initializes Firebase. The MyApp class creates a Flutter application with a simple UI that indicates the integration with Firebase is ready. Command line applications. Dart is not just for web or mobile applications. It is also a powerful language for command line applications. These applications read from and write to the console, can take arguments, and automate tasks. Here's a simple example. This example shows a basic Dart command line application. It starts by importing Dart.io, which is necessary for I/O operations. The main function takes an optional list of strings, which are the command line arguments. We ask the user for their name, which they can input into the console. The sdn.readLineSync method reads a line of input from the console. Lastly, the program prints a welcome message including the input name. Working with files and directories. In Dart, to check if a file exists, you can use the exists method on a file object. Let's see how you can perform this check. In this code, we import the Dart.io library to access I/O functionalities for files. We create a file object with the specified file path. Next, we use the await keyword with the exists method, which returns a future bool, indicating asynchronously whether the file exists. Finally, we print the result. Interacting with operating system. Dart provides the Dart.io library, which contains classes and functions to interact with the operating system. You can perform tasks like file I/O, networking, running processes, and accessing system information. The code imports the Dart.io library, which is necessary for I/O and process interactions. It first retrieves the environment variables and prints out the path variable. Then it runs a process, which in this case is the ls-l command that lists files in the directory in long format, using process.run. The results are captured in process result and printed to the standard output. Best practices. When designing public APIs, you should ensure they are clear, concise, and maintainable. Users of your API rely on the interface you provide to interact with your code. In the code, we define a car class with a private mileage field. We expose score mileage through a public getter mileage, which allows us to control how the property is accessed without exposing the internal representation. Code style. Effective Dart provides style guidelines to help you write code that is not only functional but also clean and consistent. One fundamental aspect of this is code formatting. Consistent code style improves readability and maintainability across a code base. In this example, notice the consistent use of curly braces and indentation. Even when not strictly necessary, like in single statement blocks, using curly braces can help prevent errors and improve code clarity. Always indent your code within braces to clearly delineate block boundaries. Documentation. Documentation is a critical aspect of coding that helps others understand the purpose and usage of your code. In Dart, you use comments to document code. The // indicates a documentation comment in Dart, which can be processed by tools like Dart.doc to generate HTML documentation. This type of comment should be used to describe the purpose and behavior of methods, classes, and other members. Design patterns in Dart. The singleton pattern ensures a class has only one instance and provides a global point of access to it. Below is an example of implementing a singleton in Dart using a private constructor and a static field. In Dart, The singleton pattern can be implemented by making the constructor private, singleton.internal, and providing a factory constructor that returns the same instance. The static field, instance, holds the sole instance of the singleton class, and the factory constructor, singleton, serves as the entry point for accessing it.